Hello, hello. How's it going, students? I hope everybody is doing fine and well today. We are going to go over G proteins. This tends to be a concept that comes up often. They disguise it as cardiology pharmacology questions or pulmonary pharmacology questions. They disguise this as GI questions. They disguise this as renal questions. So we see it spread all throughout pretty evenly. So I find it to be best to let's just attack it right away. I want to start off with everything associated with acetylcholine, okay, and the muscarinic receptor. So let's talk about that first. So whenever they mention the word acetylcholine, I want you to think the term cholinergic. I want you to think the term muscarinic. I want you to think the term nicotinic. I want you to think the term parasympathetic. I want you to think the term rest and digest. I want you to think dumbbells. I want you to think, let's see, we have 3, 6, all wet. All wet, right? Secretions. All right, so what does dumbbells mean? Dumbbells is basically just saying rest and digest, basically saying parasympathetic. So remember, parasympathetic means rest and digest. It means dumbbells. It means diarrhea, urination, meiosis, bradycardia, bronchospasm, erection, lacrimation, and salivation. See, all wet. That's dumbbells. So this is parasympathetic, rest and digest. Not to be confused with sympathetic, fight or flight, which we'll get to in a second. Okay. So this is the main idea first. I want you to all know that first. Now, second thing. In regards to muscarinic versus nicotinic receptors, this is what I need you to ask yourself. Ask yourself one of two questions. Is this tissue skeletal muscle? Or is this tissue ganglia? Now, if the answer is yes to either of those, it is nicotinic, okay? If the answer is no, then by default, it'll be muscarinic, okay? Example, acetylcholine goes to, let's say, my bicep, and it causes flexion, right? Muscle contraction, okay? So I would say, would that be via nicotinic or muscarinic receptors? And you'll say, well, because it's in the skeletal muscle, it'll be nicotinic. What about the adrenal medulla? Well, the adrenal medulla is ganglia, so therefore, nicotinic. You see that? But what if I were to ask the eyes, the bladder, the gallbladder, the uterus, stomach, right? All that would be muscarinic by default, okay? So that's the first thing. Now, let's get into some receptors. We have M1, M2, and M3. M1, for the most part, I want you to think of brain, right? That's my brain, and eye, okay? Brain and eye, brain and eyes. M2, predominantly in the heart, okay? The SA node, all right? And M3, all else, okay? All else, everywhere else, all right? So M3 is the one that's associated with being all wet. You see? So basically all you have to say is, well, if I'm resting and digesting, right? Am I going to have meiosis or mydriasis in the eye, for example? You say, well, I'm resting, I'm chilling, right? So I have meiosis. Great. What about in the heart? What would I have, tachycardia or bradycardia? Well, I will have bradycardia. You see, because I'm relaxing. And then everywhere else, we already went over that. Dumbbells, diarrhea, urination, salivation, etc. Okay, good. So that's that. Now let's get into sympathetics. Un momento. Here we go. Sympathetics. Sympathetic, okay? So whenever they say sympathetic, you're going to think norepinephrine, epinephrine, even dopamine from time to time, right? Even dopamine. You're going to think the term adrenergic. You're going to think the term sympathomimetic. You'll see catecholamines. What else? Yeah, those are some of the high yield buzzwords for this one. Okay. Oh, here's another one. I'm sorry. Fight, or flight. Okay. Or you could think the opposite of dumbbells. So if there's diarrhea in dumbbells, well, if I'm fighting somebody, or if I'm being chased by somebody or someone or something, there's no time for diarrhea. I have to keep those sphincters closed, right? There's no time for it. So that's the idea. Fight or flight, it's going to be the opposite. You want to think of it the opposite of dumbbells. So instead of meiosis, you have mydriasis. Instead of salivation, you'll have a dry mouth. You see? So that's how I want you to look. I want you to think of it that way. All right, great. So when it comes to sympathetics, I want you to think more, or actually just main focus I want you to focus on right now is alphas, alpha 1, alpha 2, beta 1, beta 2. Okay? I really need you to understand these guys. And here's the thing. Alpha, all these are brothers and sisters, right? It's just that alpha 1, beta 1, and beta 2, they're blood related. Alpha 2 was adopted. What does that mean? That means it's a little different. See? So whenever I stimulate the blood family members, alpha 1, beta 2, I get a lot of sympathetic activity, a lot of activity, right? Tachycardia, vasoconstriction, mydriasis, etc. But if I stimulate alpha 2, because he's a little different, adopted, he actually does the opposite. So when you stimulate alpha 2, you actually decrease norepinephrine. See? So decreasing alpha or stimulating alpha 2 would be ideal for pregnant women who have hypertension, such as alpha methyl-dopa or clonidine. You see? All right. Now let's move on to where do I find each of the following receptors. So alpha 1 is mostly seen in the eyes and in sphincters and blood vessels. Okay? Alpha 1 is mostly seen in the eye, sphincters, and in blood vessels. And what does alpha 1 do? Well, in the eye, mydriasis. In the sphincters, we just mentioned, keeps the sphincters closed. And in the blood vessels, it causes vasoconstriction. Great. Alpha 2, where is he found? He's found in the brain. And as I mentioned, he'll decrease norepinephrine release. So if I have a lot of alpha 2 activity, then that can actually potentially lead to like mental lethargy, confusion, somnolence, slowing down of mental activity, right? Okay. What about beta 1? Beta 1 is found in the heart predominantly, right? Up in the SA node. And we have some beta 1 also at the kidneys. Okay, the afferent arteriole. It increases renin release. Okay, increases renin release. And if I increase renin, well, then what happens? Well, as you know, renin's increased and angiotensin, aldosterone, see, is increased. And that causes a reuptake of water, increasing your plasma volume. It causes vasoconstriction via alpha 1 of the efferent arteriole, you see? All right. What about beta 2? One word for beta 2, all right? One word. The word is relax. What does beta 2 do? He helps things relax. Well, what does he help relax? Well, he's found in the lungs, right? He's found in the lungs. Let's put it up here. He's found in the lungs. He is found in blood vessels, right? And he's found in the uterus. I'm going to try to draw a uterus here. We got some fallopian tubes. Bam. All right. Okay, great. So let's say we got a uterus, little happy face right here. And what does it do for the uterus and the lungs and the blood vessels? It helps them relax. So bronchodilation, vasodilation, and, well, relaxation of the uterus, let's say to prevent preterm labor. You see? All right, great, great. So that's beta 2, beta 2. All right. Now, we did alphas and betas. Now let's get into the G proteins.